I also want to talk about the power rule. You can also use the power rule to find derivatives of root functions. So again, the power rule is if f of x is equal to x to the n, then the derivative is, I hope you remember, n times x to the n minus 1. That's one way to write it. And the other way to write it is, well, there's many different ways to write it, but these are the two different ways I want to emphasize, is n x to the n minus 1. Okay, so we already talked about that. I just want to explain to you how to do that, how to find, say, the derivative of, say, square root x. Believe it or not, this falls into using this rule. We can use this rule to find the derivative of this function. What we have to remember is that, do you remember this little rule from algebra here? That when you have x to a fractional power, this is the same thing as the nth root of x all to the power of m. Okay? And it's also the same thing as the nth root of x to the m. So the number on the top, m, is your power, okay? Whether you put the power outside of the brackets or under the root, it doesn't matter. And this n is the index of the root, okay? So for example, x to the 1/2 is the second root of x all to the power of 1. I won't bother writing to the power of 1 because that doesn't do anything, right? The power of 1 just keeps the number the same as it is. So this is what we have to remember to use our rule here. Now, often you're going to find that before you do the derivative, you want to rewrite your function in a nicer way. I call it preparing the function to take the derivative, okay? So let's prepare this function by rewriting it in a different way. Instead of using the root symbol, let's write it as x to the half. Now, I haven't done the derivative yet, okay? I've just rewritten the function in a different way that's more convenient for me. Now I think you'll see that we're able to use the power rule now, right? N is going to be 1/2. So let's do the derivative. As we saw, we bring the exponent to the front, make it a coefficient. And then up top here, we do n minus 1. So 1/2 minus 1. Now a half minus 1. Do we know what that is? I hope so. A half minus 1 is, let's get a common denominator by writing 1 as 2 over 2. 1 minus 2 is negative 1. So that difference is just equal to negative 1/2. And so there's our answer. Now, we usually like to give our answers without negative exponents if possible. So why don't I rewrite this as 1 over 2x to the positive 1/2. And I know it's strange that we went from the root symbol to the fractional exponent. And then what I'm suggesting now is let's go back to the root, okay? We could leave our answer like this, it's just fine, but x to the 1/2, it's kind of nice just to write root x, right? It doesn't matter. And by the way, you know that this, when you have the little 2 there, you could just write this, right? When you see a square root sign with no number there, there's really a little 2 hiding there, okay? So this is probably the best way to write your final answer. Now, here's what I suggest. I suggest you memorize this, okay? Just like I asked you to memorize the derivative of x is 1, I would also like you to memorize that the derivative of root x is 1 over 2 root x. The derivative of root x is going to come up a lot, and some students are stubborn and they don't want to memorize this, and they have to do this sequence of steps every single time. If you want to do that, that's fine. But you will save yourself some time if you just say to yourself, the derivative of root x is 1 over 2 root x, okay? And it'll it'll pay some dividends if you just memorize that instead of doing these steps every single time. So this is good. And let's just do a couple more examples just to nail this home. Let's check this out here. How about the derivative of the fourth root of x cubed? This can be done with the power rule. Let's first of all, though, rewrite it. Let's prepare this function by rewriting it with a fractional exponent instead of a root symbol. Based on that little rule I mentioned before, this is the same thing as x to the power of 3 over 4. And I think we already did this one, but let's do it again. 3/4 comes to the front. X to the power of 3/4 minus 1. Notice there's no more prime symbol, right? Because now the derivative is done. Over here, there's a prime symbol still because we hadn't done the derivative yet. We just rewrote the function into a more friendly form. But now we've actually done the derivative and the prime sign disappears. So at this point, the derivative is found. There's no more derivatives to be done, but you can simplify, right? As we saw before there, 3/4 minus 1 is negative 1/4. And we bring that to the bottom for good style. Make it into a positive exponent, okay? All right, good. Now, we can even get a little bit weirder. What about something like this? 1 over, say, the 6th root of x. Now, this might not look like a power rule at all, but it is. Because we can rewrite this in a nicer way. So let's try that. Of course, let's begin by rewriting the 6th root of x as x to the power of 1 over 6. I haven't done the derivative yet, have I? I'm still preparing this function. Now at this point here, it's still no good because we know the derivative of x to the n. This is not of the form x to the n. It's 1 over x to the n, so it's not good enough. But we can bring this to the top level and just make it as x to the minus 1 over 6. There's really an over 1 there, but I don't want to write that because it doesn't make it as clear as it can be. Now we're in good shape. This is x to the n now. N is negative 1 over 6, right? So let's find the derivative. Negative 1 over 6 becomes the coefficient in front. And we have to, our new exponent becomes negative 1 over 6 minus 1. Now, what is negative 6? Negative 1 over 6 minus 1. Let's get a common denominator by writing 1 is 6 over 6. So this is the same thing as negative 1 minus 6 all over 6. And that's negative 7 over 6. So here we go. This is negative 1 over 6, x to the negative 7 over 6. And we can rewrite this with a positive exponent as follows. Positive 7 over 6. And there would be our answer, okay? This is a separate computation. All right, so sometimes you have these expressions which need to be simplified somewhat before you take the derivative. Notice here we have a prime, which means we haven't done the derivative yet. But right here, the derivative sign is gone, which means we have finally computed the derivative of that. So this is using power rule to find derivatives with roots in it, root symbols, okay? So just be aware of that, and I would highly suggest that you memorize this little formula right here, okay? So memorize this power rule, of course. Memorize the derivative of x is 1. And memorize that the derivative of root x is 1 over 2 root x. If you hate memorizing, I don't blame you. And you really are stubborn, you can just follow these rules every single time. And you will get the right answer in the end, but it will cost you a little bit of time. All right, good. So we're making progress here and learning our rules for derivatives. Let's stop this video now, and we'll do some more in the next one.